Hello, dear friends. Welcome back to my channel. So, actually, earlier the channel name is Veerasangappa Malgi. Then it is converted into Maths for Everyone. So, later the channel name finally decided as VSM Tutor Channel. So, the videos has stopped almost 2 years back. Before COVID, I stopped to make the videos. So unfortunately, I couldn't able to make any videos so far. So after many requests, so this time onwards, I'm preparing and I'm uploading videos for the benefits of my students. So today, I'm going to discuss about one of the important topic in mathematics, especially for engineering mathematics. So very important topic that is we're going to discuss. So that is mean value theorem concepts. So in mean value theorem concept, we have the basic fundamental theorem called Rolle's theorem. So this is the fundamental theorem to prove all mean value theorems. So what are the prerequisites to state this Rolle's theorem? So the prerequisite, everyone should know what is continuity. Everyone should know what is differentiability. That means when we say that the function is continuous and when we say that the function is differentiable. So based on this Rolle's theorem is dependent. Okay. So now I'll move on to the uh, statement of the Rolle's theorem and its geometrical interpretation. How to state Rolle's theorem? Very simple. If I consider a simple real valued function. So usually we're supposed to use the term real valued function. Suppose if I consider a simple real valued function f of x, it should be defined over the interval a comma b. Then there are three conditions are there. The first condition, the function should be continuous over the interval a comma b and the interval should be closed, and the function should be differentiable over the interval AB and the interval should be open. And the third condition of Rolle's theorem is f of A equal to f of B. So if you all these three conditions are holds good, then there exists at least one point. Please, a very, very important point this, my dear students, please understand. Then there exists at least one point. It may be more than one point, but at least one point. C in the open interval a comma b, that is a should be less than c and c should be less than b, such that f dash of c equal to 0. This is exactly what the statement of Rolle's theorem. Very simple. So in the 12th standard or 11th standard, everyone might have done continuity part and differentiable part. So to define this Rolle's theorem, the function should be continuous over the closed interval. The function should be differentiable over the open interval and f of a equal to f of b. So what exactly meaning of continuity? What exactly meaning of differentiability and f of a equal to f of b in geometrical way? So that we are dealing with geometrical interpretation part. So once if we cover this Rolle's theorem theoretical statement, then I'll move on to the geometrical interpretation of this Rolle's theorem. So how to represent or how to express this Rolle's theorem geometrically, that is very important. So I'll just move on to this geometrical interpretation. So what are the statement or conditions we have covered in Rolle's theorem? So a real valued function, f of x should be a real valued function. See here, I'm taking one simple real valued function. Based on that, I'm just explaining the geometrical interpretation. See, this is, I'm just considering one simple real valued function f of x, and this function should be defined in the interval a and b. The function should be defined in the interval a and b. Now, so the first point in the Rolle's theorem states that the function should be continuous. So everyone know continuous means there are no gaps, there are no breaks. Okay. So if we draw one simple curve from the point A to point B, the continuity indicates that from point A to point B, there are no gaps or there are no breaks in the curve, including at the endpoints A and B, because we said that the function is continuous in the closed interval A comma B. Closed interval means we have to include the endpoints also. We have to include the endpoints also. So there are no breaks or gaps in between A and B for the given curve and including at the endpoints. Hence, the function is continuous in the closed interval A comma B. Then the second point what we have said is the function should be differentiable in the open interval A comma B. The function should be differentiable in the open interval A comma B. So how to explain this? A unique tangent can be drawn at each and every point on the interval. So a unique tangent can be drawn at each and every point on the interval except the endpoint. So we cannot draw any tangent at the endpoints. That's why it is open interval. Open interval meaning we have to exclude these 2 points. We have to consider between these 2 points, but we have to exclude this A and this B. Okay, so the function is differentiable in the open interval A comma B. Also, one more important term I'm supposed to use for the differentiable. So in geometry, we can also tell differentiable indicates smoothness of the curve. Smoothness of the curve. So the curve will be very smooth from the point A to point B, excluding at the points A and B. So the second differentiability condition is also holds good. Then I'll move on to the third important point, that is f of A equal to f of B. So what exactly the meaning of f of A equal to f of B? So usually how we are writing function y equal to f of x. Okay, if I define this f of x at the point A, that is f of A, that means this is y axis. This is y axis. Okay, f of B means that is also y axis point. Okay, so if I draw one perpendicular line from x axis to the curve, so this acts as height from x-axis to the curve at the point A, and it is denoted by f of A. And this again perpendicular from the x-axis to the curve at the point B, and this is denoted by f of B. So these two heights are same. These two heights are same. When these two heights are same, all the three conditions of Rolle's theorems are satisfied. So once all the conditions of Rolle's theorems are satisfied, there exists at least one point. It may be more than one point. Here I have taken 2 points, but at least one point C such that f dash of C equal to 0. So that is the Rolle's theorem statement. So if I draw a tangent for this curve, so what exactly this indicates? It is the line parallel to x-axis. It is a line parallel to x-axis, that is tangent. How to denote tangent? It is dy by dx. So that is derivative at the point C, that is f dash of C equal to 0. This is how to represent geometrically the Rolle's theorem. So finally, I'll just conclude the point conclusion, so that there exists at least one point C. So the conclusion says there exists at least one point C between A and B such that the tangent is parallel to x-axis. My dear students, it is very simple concept and very interesting concept. Okay. Now I'll move on to the problems on this Rolle's theorem. So how to solve problems on Rolle's theorem. Okay, so I'll just take one simple example. So it is most commonly solved example in most of the textbooks. Okay, so this is the verification problem. Verify Rolle's theorem for the function f of x equal to x square in the interval -1, 1. So how to go ahead with this problem, that is solution part. Suppose they have given a real valued function as f of x equal to x square. So to prove or to verify Rolle's theorem, so what are the conditions? So first condition, the function should be continuous. Since it is a polynomial term, x square single term, so we can easily tell that it is continuous. We can easily tell that it is continuous. Okay. So clearly f of x is continuous. F of x is continuous in the interval, closed interval -1 comma +1. And also we have to easily differentiate this function. X square is easily differentiable. Okay, so clearly f of x is differentiable in the interval -1 comma 1, that is open interval. That means derivative f dash of x exists. So what is f dash of x? So x square differentiation is 2x, so that term exists. Then we have to check the heights from the x-axis at that particular point, -1 and +1. So that is f of a equal to f of b condition. So this is our first condition, continuity holds good, differentiability holds good. Third condition is f of a equal to f of b. So f of -1 means we have f of x as x square. So if I replace x by -1 in the function, so it is -1 whole square, that is +1. Also f of b is also 1. So if I replace x by 1 here, it is 1 square, that is also 1. So based on these two, we can easily tell that f of -1 equal to f of +1, that is nothing but 1. So here you can see all the three conditions are holds good. Then we can easily tell that there exists at least one point C in the open interval -1 comma +1. And now our job is to find out what is the C value using Rolle's theorem. So if there exists a point C in the open interval -1 comma 1, so Rolle's theorem statement says that such that f dash of c equal to 0. F dash of c equal to 0. Now how to find out this f dash of c? See, that is very simple. In the given function, what term we have? F of x equal to x square. If I differentiate this, what I'll get? F dash of x equal to 2x. So if I replace x by c here, I'll get f dash of c, that is 2c. So I'll just replace the 2c here. Therefore, f dash of c equal to 0 is nothing but 2c equal to 0. Here 2 cannot be equal to 0. So only option is c equal to 0. Now, whether the C belongs to the open interval -1 comma +1, we have to check. Suppose if I draw -1 comma +1 here, definitely 0 somewhere lies between in -1 to +1. Therefore, we conclude that C equal to 0 belongs to the open interval -1 comma +1. Hence, the Rolle's theorem is verified. Hence, the Rolle's theorem is verified. So very simple. And if we know basic differentiation here, it is very simple. And also one more important point you have to remember when with respect to continuity and differentiability. See, all differentiable functions are continuous functions. That means if you come to know the function is differentiable, you can easily write that it is continuous also. But the converse part is not true. All continuous functions need not be differentiable. Please keep that in mind. So this is one simple example with respect to Rolle's theorem. I hope this lecture will help you to understand the method for Rolle's theorem. So kindly practice this, and uh, in comment box, please put your comments. So thank you all. We can meet with the next video.